So welcome. We're going to go through a review today. So Tuesday is your exam. Next Tuesday exam. It will be in the Ingman lab, so same format as what it's been in the past. So make sure you bring all the materials you need. If you're going to take it on your own laptop, iPads, whatever material you need to bring. I thought so. Are they not? Maybe they are not. Okay. Sorry, give me a second to upload these. Thought I had.
Food, ice cream, dessert.
So sorry about that. I thought I had done that.
You're making me
Okay, try refreshing it and seeing if you have access now. Okay, sorry about that. Thought I had done that, but did not. Okay. So, topics that will be on the exam. So, AC signals, dB, understanding those, Bode plots. So you're going to need to draw the Bode plot, understand and interpret the Bode plot. From that, also being able to identify what type of filter it is from a Bode plot, understanding the Q point, does it have a high or low Q, and then what is that cutoff frequency if it's like a low pass or high pass, what is that frequency where it either passes or doesn't, and then band pass, also again, whatever that middle frequency, omega naught frequency is. LC resonance circuits, just understanding how to calculate the resonance value of that, what it is, and then a diodes question. So I had a request from a couple different people to do harder diode problems in here, for example. So we'll go through a harder diode example, and then I have a couple of them if we have time to go through both of those. All right, questions about what will be on the exam? Okay. So, being able to convert the following voltage gain attenuation to dB. So your V out is 17 and your V in is 19. So 17 over 19 volts per volt. So take a second and try to, actually, why don't you guys work on both of these? So this one's conversion to dB, and then this one is a resonance frequency. So the LC resonance, calculating what that resonance is. I'll put it right in the middle of those. There we go.
Did that. I know, I kind of felt bad. I was like, I'm very not. Values for CI. I don't really need to walk in that. Yeah, like I go to that usually every class. Or I like grabbing yeah, I need a break in that class. Explain to me what's going on. A lot of things. That should be opened up series. No, that's not Log number, what did you say? Like you're close enough. These are just random. Sometimes they make you
Okay, so the conversion should be the V out over V in. So your output is less than your input, so you expect it to be a negative number. And it ends up being a negative 0.97 dB. All right, questions on converting those? Okay, to find the resonant frequency, I don't have resonant frequency. To my okay, what is the equation for, okay, wrong ones. Wrong course. There we go. Okay. So the LC resonance, you guys remember? The notes go 16, annotated. So remember when we derived this? We did it both in the time and the frequency, and they ended up being the same. It's the 1 over the square root of LC. So your resonant frequency when you have a combination of them in series was that 1 over the square root of LC. So for this one, you just have to. Oh my. There it goes. So in this case, 1 over the square root of LC, whatever those values would be.
And so that's what it's always going to be if it's in series?
Yep. And the reason why is because remember when we were doing this, you were making it so that the components cancel each other out. So the L component cancels out the C component, so all you're left with is a real component. And that's when it gets to the peak on that one. So that derivation was that it just ends up being 1 over the square root of LC. So it's only when they're in series together.
Can you have multiple in a row?
Uh-huh.
Capacitors and inductors, can you just find the equivalent?
Yep, between each one of them as a pair.
Okay.
Yep. Or you can do like 1C and then put 1 L and then put 2 C's together that add together to be the same.
But you couldn't have 2 L's in a row?
Again, their value would have to add up to be an equivalent of them together. If that makes sense.
That makes sense. Thank you.
Uh-huh. All right. Okay, so this is your harder diodes question. So you're going to assume that both are on. So assume both of these two are on, and then redraw the circuit and analyze them to see is that a correct assumption. Find the value of V naught here. And then also calculate ID1 and ID2. So try to get to these values. So use 0.7 volts for the drop.
Actually learned didn't know what that was. Situation slash stroke slash labels or
You want to accomplish that?
Would be not over here. Over 1.9. Okay, so a couple questions. One is, how do you know what direction is for the plus and minus on the source? Correct. Remember that line? That's going to be your negative side. So plus and minus would be this direction. And then on this one, the line is on the bottom, so the plus would be on top and the minus on the bottom. So that's going to determine which direction the polarity is. The current should go also in that plus to minus direction. So this one should still flow up, but sometimes you may not be drawn the ID1 and ID2. Here they were drawn. All right, so to find V naught, hopefully you can see like, well, there's already just voltage there. So you could just take a pathway from the negative 20 through the, sorry, I didn't label it, but 0.7, and that would give you the voltage here at V naught. So V naught would be a minus 20 plus 0.7 for a minus 19.3 volts.
Can you explain that again?
So to find that voltage, it's going to be either the pathway from here. So remember when you have a dot or an arrow that has a voltage on it, that is in relation to ground. So that goes from minus 20 from that point to ground. So I could redraw that and it would be actually this with a minus 20 volts source. So that gives me a reference from ground to that point is minus 20. Then I go through this source, circle these. So this would be a plus, minus 20, and a plus, and that would get me to V naught.
Gotcha, okay, thank you.
You could also, if you knew the current in this branch, you could use that times the 1.93K, but you don't know the current. So voltages, you're like, I know those voltages. I'm going to use that pathway. Yes.
Do you not have to worry about any voltage coming from like the other branch, from the other battery?
Again, you don't know, like here it's going to be from this plus 10, you know, you could redraw that to be a plus to minus 10 volts. That's the same. I guess I can physically draw that. That's the same. I can physically draw this down here too. That means the same thing. If I took it from there, I would go through the 10 volt, also through this 0.7, and then also through this resistor. But I need to know that current again.
I meant like the one going across.
Across.
But you just found the voltage at V naught just from the negative 20 volts. But is there not any voltage from like the other two branches going out of it?
Yeah, but they're all at the same node. So remember, a voltage is going to be everywhere that wire goes. So in this case, it's going to be all of this wire is V naught. So then to find the voltage there, it's either, it could be, you know, this pathway to ground. It could be this pathway to ground. It could be this pathway to ground, or it could be this pathway to ground. They're all in parallel to each other. So to find it in the other branches, the 1.93K, I need to know the current, because it would be I times R there. I would need to know the current through the 5K to do that drop, plus the 0.7 plus the 10. Or I'd need to know the current through the other 1K and the 5.3 volts. Since I don't know those, that's harder pathway to take. So you could still find it. It's just going to take you a little bit longer if you, with all the algebra, to find it. All right. So that gives me V naught. So one thing to notice here is I took the pathway that had the most information in it. Voltages or known information. So this is kind of any problem solving that you want to do, is you always think about what information do I know. All right, to find ID1 here, I know across that resistor, I know V naught, and I know the voltage at this node. What is the voltage at that pink node? Maybe I'll make it green. At this green node. Minus. It'd be 10 plus 0.7. So going from the ground. So now ID1 can be the Ohm's law, which is across it is the minus 19.3 minus 10.7 over 5K. So once I get the values, what do I need to do to check to see if these were accurate? Correct. So this ends up giving me a minus 6 amps. And then the check is that ID is greater than 0, which it is not. So we would say this is actually not on. So then I would maybe make the assumption that the bottom one is on and then the top one is off.
Do
Yes.
you want us to redo that if we see that it's negative? Because I saw in the homework you're allowed to get negative values, so.
That was because it stated specifically what to assume.
Yeah.
So in this one, it said assume both are on and find the values for that case. If it will be a simpler circuit if it's like do it multiple times in order to do it in the time frame you need.
For the most part of the problems, they're just gonna say assume that they're on or off.
Mm-hmm.
Okay.
But let's say like, okay, we are gonna redo this one. And we want to say that this one is off and the other one is on. So here we assume on for the bottom one and off for the top. So V naught is going to be the same, minus 19.3. How do I find ID2? Because that one needs to be checked to see if it's on. Any thoughts? Yep.
Real quick, why did you do the negative 19 minus 10 instead of doing like the final minus initial? So just because it's like gaining voltage instead of losing it?
This right here, you mean the current?
Yeah.
So I just used Ohm's law. So this is Ohm's law, where it's the voltage across it over the resistance. So I took the voltage, in this case, it's V naught minus,
I think I was just confused why it's not like the 10 volts or 10.7 minus the negative 19.3, because that's like which way the current's going.
I see. So the current, you take the positive side first, minus the negative side. So it depends on the direction that current is specified. In this case, it's specified as going up, so the positive's on the bottom and the negative's on the top.
Okay.
So positive side first, then the negative side. If the current was going down, then you would take 10.7 minus 19.3, or minus a minus 19.3.
Okay.
Does that answer? So it's not necessarily, so yeah, do look at where it's going, and then that plus and minus on the arrow side. Okay. All right, any other questions? Okay, so to solve this, we can't write an equation easily for ID2. So we would need to solve for I1 and then I2. So I1 is going to be what? Correct. Minus 19.3, which is the voltage. On this side, minus 0 over 1.93K. And then what is I2 going to be? What's an equation for I2? Voltage on this side. Plus 10. And then the voltage on the other side. So minus 19.3 plus 5.3. over 1K. Yeah, so they're just batteries in a row.
So you just go from ground to that side
Uh-huh.
from both? Okay.
Yep, you go from ground to that node is gonna be, minus 19.3 here. And then you add the 5.3, so that gives you the voltage on the other side of the resistor. So -10 minus, so this is 4, the -4? Yeah, -4 milliamps. So now a current summation would be ID2 goes out, I1 goes out, and then I2 comes in, which would give us an ID2 of 10 milli. Oh wait, wrong way. I2 minus I1. So that's going to be -4 minus 10. So is it on or off for minus 14 milliamps? So this one would be off. So, or not on. So then you would need to make a different assumption. You could assume they're both off and then check that one. So this is just an example of that iterative process of if it doesn't match the assumptions, you would need to make a different choice. All right, questions on this? Yes.
The voltage difference between like the
Okay, we're gonna do a side step here. I can see where people are going. Okay. Somebody choose direction of current. Left to right or right to left?
left to right.
Okay, left to right. Current's going to go in this direction. I'm going to do a 1K here just to make it easier. Okay, voltage at this node. Okay, good. Okay, 6 minus 5, 1 volt. Voltage at this side. Correct, minus 4 volts. So you're comparing everything from ground. This would be adding these away from ground, and this one is those. So I1 is going to be what? Correct. So you take the plus side, which is this side, that's 1 volt. Minus side is a minus 4 volts. So then it would be 5 milliamps. Is that helpful?
Yeah.
Okay. So practice. It's a little bit easier to do these, a little bit harder to find those voltages on each side of the resistor. Yes?
How is I2 not 24 milliamps?
I2?
Yeah, you have it as -4. I believe that.
Oh, I think you're right, actually. It would be a minus 19.3. That would be plus.
Yeah.
24, thank you. It is on. I was like, I think it was on. Yes, my math error. Okay. This would be a minus 19, so 24 over 1K, so 24 milliamps. A plus 24 milliamps. So then this is 24 minus 10 for a plus 14. So plus 24 milliamps minus 10 plus 14. So this one would be on. So we'll go through the rest of this. So ID2 is greater than 0, so yes, check. And then up here you need to check for off. The off check is that VD is less than 0.7 volts. So what's the voltage on the plus side of VD? Correct, negative 19.3. And the voltage on the negative side, correct, negative 10. So it'd be a minus 10 for a minus 9.3, which is less than, or 0.7, so it is off.
Is it negative 10 or should that be positive 10?
Sorry. Yeah, it is plus 10. Negative plus 10. So negative 29. Oh my. It is one of those days. Negative 29.3 volts. Glad you guys are checking my math here. Not doing well with my algebra today. All right, questions on this? Yes. Sorry, what was that?
Why is I one not negative?
Well, you
I1 not. Okay. Negative 10 milli. That would become a negative 10, so plus 10 for 34 milliamps. Which is still positive, so it will be on. Any other errors that... I'm glad you guys are on top of it today because I am not. Okay. So now I think it is correct. As long as I didn't make other algebra mistakes. Okay. Yeah, we might have time for both. Okay, so moving back to Bode plots. So Bode plot, we want to draw this equation. That's already down there. So recall that the steps for Bode plots is you want to put it into standard form. So the standard form, remember, is what? What do we need to do to this to get it in standard form? First off is the top part in standard form. Yes. Okay. So yes, it is. So we're going to leave that alone. Is S plus 1 in standard form? S plus 1 is. But the 1K is not. What do we need to do? Bring out the 1K. And that will turn it into this. And then we take the 100 divided by 1K. So that just leaves 100 S on the top and an S plus 1 and an S over 1K plus 1. So, yes.
What's the S dot?
Typo. Doesn't mean anything. It was meant to be just S.
I thought this was like a differential equation.
Yeah, S prime. No, sorry. That was just a copy error that the copier had on it. All right, so from here, what are your... Yeah. So remember, for standard form, you either want a number times s or some number s plus 1 as the quantity. So how many zeros do I have, and what zeros do I have? How many? We have a 0 at the origin or 0 at 0. So 0 at the origin. How many? So only 1 0. How many poles do we have? Correct. 2 at where? Correct. And remember, we don't necessarily write the 1 negatives because that just means it's on the left side and it's stable. So we just are looking at the magnitude of those when we're talking about them. So a 1, a pole at 1, and a pole at 1K. So I'm going to kind of circle that. So 1 and 1K. How do I know where to start on this graph? So before 1, what do I know my value to be? How do I determine that? So what is the 0 doing to my graph? Correct. It's going to have a slope. I just don't know where that slope is going through my graph. So since I have a pole at 1, I want to take something probably 1 decade before that and calculate it. So I'll give it a little bit more room. I'll say this is my point 1, and I know at this location I have a line going through it. I just don't know where exactly it's going through. So I need to find that location. So to do that, I would take the magnitude of this. So I need to find a starting value. So taking the magnitude of 100 and then the magnitude of s when it's at 0.1 will just be 100 times 0.1. This will be 1 squared plus 0.1 squared. And then the square root of 0.1 over 1k squared plus 1 squared. So that ends up being so it's approximately log approximately 20 dB. So if this point here is 20 dB, put 20 dB. Assume it's right there at that dot, which puts this at 20 dB. What value will I have here at 0.1? Or at 1, I mean. It would be 40 dB, correct. So it's a slope of 20 dB per decade. What happens at 1? Correct? It goes flat. Good job. Because it will add on the slope with the first pole, which would be a minus 20 dB. And then what happens at 1K? Correct. At what slope? Correct. So negative 20 dB down. So my slopes aren't even, but this goes down by negative 20 dB per decade. And there's my Bode plot. So some of the questions. So at 0.1 radians per second, it was approximately 20 dB. The zero frequency for this circuit is at the origin. The pole frequencies from smallest to largest is a 1 and a 1K. And what is their units? Correct, radians per second. The slope of the magnitude from 0.1 to 1 is 20 dB per decade, and the slope of the magnitude from 1 to 1,000, 0, correct. And then the slope of the magnitude after 1,000, negative 20. Okay, any questions on the Bode plot? Yes?
Just go up to the part B of that, the 0 frequency.
Yep. Any other questions? Yes.
So that 20 volt and 10 equation, what equation is that?
So remember, what's the units of this?
Is that just converting your volts to CVs?
Correct. The default units, whenever you've derived this equation, is going to be in volts per volt. So you are graphing it in dB.
Yeah, I think I was just wondering like where the denominator was.
How you got this? Is that what your question is?
Like you got
Okay.
the whole denominator there.
So remember,
Use your HS.
remember when you take a magnitude of a complex number, the magnitude is the real portion squared plus this imaginary portion squared, the square root of it. So to do that, S is you plug in S is equal to j omega to find that frequency graph. And so, make sense? Okay.
Yeah.
All right, any other questions?
If you were to have like an S plus 100 like squared,
Uh-huh.
how would you take the magnitude of that? Would you like just split it all and then take the square root of all of it? Or
Yep, and then you would square that, so it'd have two of them. And so it will get rid of your square root. And then your effect has doubled with whatever it is. So if you have two poles at that, then you would have minus 40 effect. Does that make sense? Okay, other questions? Comments? Okay, here is a Bode plot graph of a filter. So what kind of filter is this? Band, which one?
Not the band reject, or the other one's called
Band pass.
band pass.
Correct. This is a band pass. What is the resonant frequency of this approximately? Correct. So this would be your resonant frequency, 10 radians per second. Does this have a high or low Q? Correct, a low Q. Remember that the high Q was when it was really steep right around that frequency. Okay, any questions on the filters? Okay, so just review and remember what the filter graphs look like. All right, here's another diode problem. Assume both of these are on. Oh, ignore the AC portion of this. Just have both those at 12.
I'm a guess right here.
Yeah. So solve for V naught and verify if ID1 and ID2 are on or not. So find ID1 and ID2 also.
It's probably not very high settings. Because I take thousands of pictures. It's good enough to show you like the facial recognition software. You just like take your photos and also just like a good I was in the break last time.
It's hard when you get an hour.
You can tell by the guy sitting on his ass in the center.
Damn, that's like. It's already so hard. I guess that's right. Every single time I get something, it's because I just
Yeah, okay, so we got this is a change voltage, but it's not. Right, but
Yeah, it goes down. 2 volts
So like, how do you do it? Yeah. It's not small for you. It's
It's like lower color. It's like it's either Florida or California. It turns out we're all.
That's turkey.
They got bikes.
I think it's right here. I mean, they're all like
I'm guessing it happened.
no way. That's what I do. I'm not good. I'm just better.
Oh yeah, you only get like a certain type. Oh, sorry. I was looking at this. For this guy here, like you started. So yeah, so And is it possible? Where's the big statue?
Wait, is it Brazil?
Well, yeah, 'cause I never guess what's in mind.
It's not one.
I bet you it's.
No, this is
If you want to guess Brazil, yeah, it is a good guess. No You're at the right Not you really don't memorize it. Look at the card. Is the card on it? Oh, this is what you asked.
Yeah, can we use this on a test?
You saw my algebra today, so I'm not trusting myself to solve for that. Okay, so that gives you 7 volts. I think most of your calculators do this too, don't they? No? Okay, Wolfram does it.
whenever I'm bad at guessing it, it's probably
Okay, so if you guys have been following what I've been doing, so set up to solve for each of the currents. So I know that the currents ID1 plus I1 is going to equal ID2. What is what? Okay, so current summation into node V0. So ID1 goes in, I1 goes in, ID2 goes out. And then ID1, I wrote the voltages next to the resistor, so it was easier to write the equations. The voltage drop across there. The current is going in this direction. So this is my plus side, that one's my negative. So plus 11.3 minus V0 over 2K. On this side, the plus is 14 minus V0 over the 1K. And then the current direction on this one has the plus V0 minus a minus 11.3 over the 2K. So substituted those in, and then solving that using an online tool because my math is not good today, gave that result of V0 was going to be X, so V0 is 7 volts. So with that, then I can go back to my ID1 equation and my ID2 equation. So 11.3 minus 7 over 2K. And that gives me a positive value of 2.15 milliamps. And then ID2 is the V0, which is 7 minus a minus 11.3 over 2K. And so that gives me 7 plus 11.3 of a 9.15 milli. Are these on? Why are they on? Correct. ID1 and ID2 both greater than 0. So therefore on. So that's my check to make sure they were on, and that's valid. All right, questions? Is this, I can't remember who asked me for the harder diode questions. Are those, so we got some thumbs up with these, okay. All right, so homework's due by tonight. Your quiz is open if you want to take it either today, but make sure you take it by tomorrow. It has an LC question and then a diodes question on it. So just make sure you know how to do those before you attempt it. All right, see you guys on Tuesday. Again, we'll be meeting in the Ingman lab for the exam.
The second part.